let's build a web server on ESP8266, means our favorite NodeMCU, into the access point mode. Now in access point mode, you don't need any internet connectivity because your NodeMCU, means an ESP8266 microcontroller, create its own network. Now in this project, you can see the code starts with an include statement. So it's basically ESP8266 Wi-Fi.h, this header file let our NodeMCU to access all the Wi-Fi capabilities, something like in access point mode or something. So it can create its own network. It will let other client devices to connect to the access point. That means our internet gateway, that's our ESP8266 and NodeMCU in this case. So all the Wi-Fi related methods we will get an access using this library. So there are the methods into this library. That's why we have to add this line of code. And then we add another include statement, which is basically ESP8266 Webserver.h, because this web server is an HTTP protocol. It uses HTTP protocol. It's an HTTP server, so it has to handle the HTTP request and responses. So it has to send the response back, handle the request, incoming request, and all those things basically can be handled by using the methods which is coming from this library, and that's why we have to add this ESP8266 Webserver.h header file. Then we have to specify the SSID and password, because as I said, our NodeMCU, means ESP8266, will be a web server. So when it's a server, then other client, means other laptop and mobile phones and other devices would want to connect to this network created by NodeMCU and ESP8266. So we have to create an SSID. That's basically the name of our Wi-Fi network. It's a NodeMCU, and we have to specify a password just for security, 1 2 3 4 up to 9. And if you don't put the password, then this network which is created by NodeMCU using a web server will be an open network. So without any password, any device can connect. It's a security flaw. That's why it's better to put the password and keep it simple, 1 through 9. Then we use this library ESP8266. It's basically ESP8266 web server class, and we create the object server and we pass the constructor as the port 80, because since this web server is an HTTP server, it has to we have to tell, okay, we are using HTTP port 80, so that the server will handle the HTTP request, right? And it has its own significance. Even if you watch my previous video, how to use ESP8266 and NodeMCU into the station mode, I have explained this quite more detail, so please go ahead and watch that video as well. And then we take a boolean bool variable LED status, and we want to keep the LED to be low in the beginning. We just want to initialize it. And then in a setup function, we initialize the serial monitor, and then we configure the D4 pin on NodeMCU. That means an ESP8266. That's where our built-in LED is connected to be an output mode, because since we want to control LED is an output device, so we have to configure it. And then we have to say Wi-Fi.soft access point. So soft AP is the method coming from the Wi-Fi class, and that basically takes two parameters. One is SSID and another one is a password, so that it will create an access point, Wi-Fi access point with this name SSID and the password. So the SSID will be NodeMCU and the password will be 1 through 9 or some number that we have specified here. So this is what it creates, an access point. And the reason why it's a soft access point is because usually when you create an access point, let's take an example of our internet router. It basically gets the internet through the wire coming from somewhere from the network. But here NodeMCU doesn't have any wired connection to initiate and create its own network. So it's basically in a wireless, so it's software defined soft access point. That's why they called it as a soft access point, and there is an access point as well. So basically, if you know, I also have spoke about this, that the NodeMCU ESP8266 can operate into station mode, access point mode, and soft access point mode. So access point and soft access point is the same thing, but station plus access point mode. So together also there are 3 configurations that can run, and the soft access point and access point is pretty much same, but as I already explained what does this means. And then we use this IP address, and then we create another object, and then we take the Wi-Fi soft access point IP address. So basically when this access point is created onto the node server, NodeMCU as a web server, then it will have its own IP address, right? Just like any internet router, it has a default IP address. And something similar when your NodeMCU ESP8266 will be acting as a web server in access point mode, then it will have its own IP address. So usually this IP address is, as I checked in a documentation, it's usually always 192.168.4.1. So if you want, you can customize it, you can change it, but I think it doesn't make any sense to change it because I read a lot of documentation. I have given the link in a video description, so you can even go through the documentation, but this is the easiest way. Otherwise you can use another method. It's called soft access point config, and you can specify the local IP address and the gateway and the subnet mask. But I would rather suggest this method is pretty much proven. It works with all the laptops and networks and other things. I have checked it. So I think I would suggest to use this method, to use soft access point IP address. So it's just assign one IP address, and that would be, as I said, this 192.168.4.1. that will be a default gateway IP address for our NodeMCU. And then we just throw the text, the access point IP address, and then we will print. So this IP address will get printed on a serial monitor, and then we will use this IP address. Okay, I can just take this. Once this code we upload on NodeMCU, then we will go to browser, and in a browser we will going to put this IP address. Okay, we'll keep this for later. I will show you live. But then later you can see we have here server.on method, and on method takes two parameters. It's basically first a URL and second is a function to invoke. I've explained about all these four lines of code in the previous lesson where I showed how to use ESP8266 NodeMCU into the station mode, and the description or the explanation remains same in both of that. But I just quickly go through it. Like when somebody call this root location, that means the IP address, when it call from the browser, then it will invoke this handle on connect function. And when somebody from the client from the browser send the IP address slash IP address means the IP address of the NodeMCU. So IP address of NodeMCU slash LED on, then handle LED on request method will get invoked, and then LED turns on. And the NodeMCU IP address slash LED off URL will be trigger when the response, the request come from the client, means a browser. The IP address slash LED off URL will trigger, and then this handle LED off will get invoked. And when if the server doesn't exist, then this on not found. So what if you create a server, web server on NodeMCU ESP8266, and that server doesn't exist for some reason, maybe some problem in a network or something of that sort, then we have to throw the message to the client. The client has to notify that the server doesn't exist. Something similar like you visit a certain website, let's say a tomato.com or something like that, and if that website doesn't exist, then it will say the server doesn't exist or page cannot found or something of that kind. So we have to specify. So this is to when the client, means the web page connect. This is when somebody press the on button. This is when we press the off button, and this is when the server doesn't exist. So this is basically a simple the web page that we want to create here. And it's basically if you want to see it, I will show you a little bit later once we upload the code. And then server.begin basically starts the server, and then you can see in a void loop function we say server handle client. So this function basically takes care the request coming from the client, and client is a browser in this case, and the server is our NodeMCU ESP8266. And then we monitor for LED status variable, and when we press the button, then LED turns on, and when we press the button, the LED turns off, depending on the location, depending on whether it call the LED on or LED off, what we call it as a routes in a URL. So based on that, you can, if you're not able to get this, I would again suggest to watch the previous video. I have gone really detailed in it, and I have given the link in a video description. So, but just long story short, this if statement checks the status of this LED, and then it will turn on and turn off, depends on whether you press the on button or off button. And then you have this handle on connect function, which basically by default the LED status will be off. So when you when you send the request to the server and client will get the web page, then the LED will be off by default, and it will print LED off on a serial monitor. And then server.send function will send, once the request come from the browser, then the server has to send browser to the client something, and that 200 OK is the HTTP response code that everything works fine. And the second parameter is what type of content we want to send is a text HTML. And then update web page function is basically generates a dynamic web page onto the browser, and it sends the status of the LED, whether the LED is on or off dynamically. And then you have the handle LED on function, which basically turn on the LED. You can see LED status is high now, and it will send the LED status, which basically dynamically generate the response of on and off onto the web page. And then we have the handle LED off function, which basically whenever somebody calls this function, then the LED status will be low, that basically turn off the LED, and then it will be updated onto the web page, and this is again sent the. So basically this send function takes three parameters. One is the HTTP response, the second is a type, the text type, and then what exactly we want to send. And what all we are sending here is basically the status of LED, because that's turn on and off the LED. And then we have this handle not found function, which basically again send the error code 404, that's basically the page cannot found. And then text, plain text we are sending to the HTML web page, and then not found will be the text will be shown into the web page. And as I said, this update web page is basically a function. Here it is defined, this function, and this update web page function takes one parameter, and that parameter is again LED status. So whether we want to turn on and off the LED status will be passed into this function. If I make this a little bit bigger, then you can see there is one variable type string. PTR is the type of the variable, and then we have to declare what are we going to send. And as we are sending the HTML web page, we have to specify the declaration that we are sending an HTML document, that means HTML web page. And then the second, this viewport is basically make our web page to be responsive on all the devices. And then this basically is the title of the web page that we want to generate on the client. And then we have this other style sheets. I'm not going to go detail in it. It's just HTML to give a little bit of styles to the font and color and other things. And then here are two buttons and its colors and other things, and you can just pretty much, it's an HTML code. So what is interesting here is to check this if statement. Okay, and this if statement basically dynamically generate the response, send it back to the web page, whether the LED is on or off. Depending on that, it's basically turn on and off the LED, and it also shows onto the browser. Depending on the status of the LED, whether it is on and off, this will get invoked, and this will be sent to the web page. Now let me upload the code and show you how it looks like. So just make sure the COM port is selected properly, and then the board is selected properly, NodeMCU 1.0, and let's upload the code. I have explained all those this entire function in my previous video. That's why I'm not going so much detail in it. It will be a sleepy video, right? So there's no point of doing one thing again and again. So I would, suggest you to check out that video, how to create a web server into the station mode. I have given the link in a video description for you to go very detailed into the code. So once the code is uploaded, then we can open a serial monitor to see what's going on. And as I said, our NodeMCU will get an IP address, and that IP address will be an IP address of our access point. That's basically our web server NodeMCU ESP8266. Now if nothing shows up onto the serial monitor, then press the reset button, and once you press the reset button, you see access point IP address is this one. So I can copy this IP address and I go to browser because that's my client, and when I paste the IP address, that's the default IP address of the gateway, and gateway is basically an access point here, our NodeMCU on which our web server is running. So once I hit enter, you see nothing comes here, and the reason is because now my laptop is a different device and this is basically a NodeMCU. So I have to go to lower right corner on my laptop, and then I have to go to this Wi-Fi, and you see now this NodeMCU access point is already shows up here, and it is because here we have created this NodeMCU access point and its password is this one. So I go back to my Wi-Fi here and I click NodeMCU and say connect, because it just freshly created, so we have to connect. It will ask us to put the password, and the password is really simple. It again set by us. So this is the password. So it takes maybe a couple of seconds, don't worry. So it says it's connected. Usually it will ask you to put the password, and you have to put the password 1 through 9. It didn't ask me because I tested this code before I started recording this video. That's why you don't see here, but it will ask. Now my laptop is connected to this NodeMCU access point, that is our internet router, and believe me, right now our NodeMCU ESP8266 is acting as an internet access point for us. Amazing, right? So we go to our browser and put the IP address and now hit enter, and you see, bam, we have the web page. And I can open this serial monitor here. Oh, where it's gone? Why my task manager doesn't shows up? Okay, so here it is, and here is my serial monitor. This happens, like, it's just the devices that goes crazy sometimes. So let me press the on button and see, I receive LED on and LED turns on NodeMCU. When I press the button, this off button, then this LED off comes to the serial monitor and LED turns on. This is how you can turn on and off the LED connected to NodeMCU from your browser by putting the URL. Now I can take my smartphone, and from my smartphone I'm going to call the same URL. So this is the URL I'm going to call on my mobile phone, and make sure your mobile phone is also connected to the same network. That means an access point, that's the NodeMCU. And when I press, look at this, the on shows up because I turn on from my mobile phone now and turn it off. So the off shows up here, and it works pretty much cool, right? It works fine. So what I wanted to show you is, you might say that I haven't spoke about this if statement here, right? If LED status, and this is all because it generates this dynamic, right? So when we press the button, this on button, when we press it, look at this, when I press the on button, the LED, blue LED, and it says on, because whenever we press the on button, then this IP address, that's our web server /LED on, will get sent from our browser to our NodeMCU ESP8266, and this is what the server has to respond back again, like on and off messages, right? So you will know dynamically what's been coming, right? So when it is on, you send off; when it's off, you send on. And That way basically you dynamically generate here the labels. So let's say when I press the off, you can see it dynamically says it's off. The LED is off on the other side, and here it is on, because when you press the button then LED turns on. Right now it is off. So when you press the on button, then that LED will turn on. That's why right now you see here off. And you can see whenever I press this button on and off, you can see here when I press the button on off, you see this URL changes, and that's basically a request that is sent from the client, means a browser, to our device. And this is our device NodeMCU, right, on a serial monitor, and accordingly the LED turns on and off. You can even test it, and this is amazing, right? I have not seen any IoT product which have not used and built on NodeMCU ESP8266 and have not used the web server on NodeMCU. Especially when you build an IoT product, you cannot able to give the Wi-Fi username and password, means access point and password, because you don't know when you build the product what will be the customer's Wi-Fi access point and the password. So you have to create this kind of web page through which you can allow your customer to set the custom access point and password. So configure this device NodeMCU sort of microcontroller chip so that the device will get connect to the internet. So it's very amazing feature. You can create this web server and do really amazing stuff and create really cool projects and products. I hope you have found this video educational and entertaining. If you want to see more content like this, you might want to check the playlist. We have amazing videos around NodeMCU and ESP8266. Thank you very much for watching this video, and we'll see us into the next video. Bye bye for now.